Hello everyone. This video is for those of you that missed class on Monday the 28th or on Tuesday the 29th. This is just calculating pressures, volumes, temperatures, and other things based on this formula right here at the bottom. Okay, so all of these can be used to calculate pressure, volume, temperature. This one at the bottom encompasses them all, but for example, if your volumes are constant, that means this number over here and this number over here would be equal to each other, which means they would cancel out, and so you don't really need them. Same thing with the number of moles down here. Maybe that doesn't apply, maybe they're the same, so those cancel out and you don't need those. So this is all, the gas laws are all encompassed in one formula here, and you should be able to use this to calculate any of the problems that are coming up. Over here you see the typical units for volume, liters. For pressure is kilopascals. P is capital because it's named after Pascal. And K for Kelvin, also capitalized after Lord Kelvin. So,
okay, these units over here also go for, are the units also, maybe milliliters are used for volume. Atmospheres, this is the amount of pressure that one atmosphere, or our normal atmosphere, puts on us from the air at sea level. And so if you think about our normal atmosphere, that would be equal to 1 atmosphere. Here you got PSI, pounds per square inch. That's the customary unit. We probably won't use that much. And then of course you guys are familiar with Celsius and Fahrenheit. Okay, when working out these problems, the first thing you want to do is you're going to want to identify all your different variables. So here we have liters, 325 Kelvin, 1 atmosphere, 2 atmospheres, 150 liters, and you write them all down with their variables so that you can plug them into the equation. Okay, so we've listed all our variables here, and then the one thing that we don't know that we're looking for here is the second temperature, or what the temperature changed to. So we put that down there with a question mark. Now we're going to plug these into our equation and make sure that we leave T2 in there as our unknown. Make sure that you place each known in its proper place in the equation. Okay, go ahead and run the numbers. So 1 times 4 divided by 325, and then put that number down here on this side. Over here we have 2 times 1.5. You can put that number over here on this side, and then make sure you leave T2 on the bottom. Okay, here's our numbers multiplied out and divided out. You'll notice the numbers here, but what you will notice also is that the units have become a lot more complicated, but it's not a big deal. Atmospheres was on top here, atmospheres was on top here, liters was on top here, liters is on top here, kelvins was on the bottom here, and kelvins is on the bottom here. We have to keep all those units. They haven't canceled out or anything. Same thing over here. We have to keep both those units so they stay. Okay, let's algebraically rearrange to get T2 by itself. Remember, in algebra you want to get your unknown by itself, and that helps you solve for it. Okay, we're going to cancel this out and move it over to the other side. Okay, everything's been rearranged. Let's go ahead and rewrite the equation to show what it looks like with T2 by itself. Okay, here's the rearranged equation. You see T2 over here by itself, our original 3 atmosphere liters over here, our new number over here on the top. Okay, so let's go ahead and divide it out, and then we'll deal with the units. Okay, we get 243.90, but what are we looking for? Well, we've got temperature here, but also let's look at our units. So we have atmospheres on the top here. They cancel out with the atmospheres on the bottom here. We got liters on the top here. They cancel out with the liters on the bottom here. So the only thing we're left with is kelvins. So our units are going to be in kelvins. And since we're looking for temperature, that works out to be great. And there's your answer. Okay, sorry about the wording on this problem. It says, give a temperature change that would cause the volume of a sample of an ideal gas to double when the pressure of the sample remains the same. Okay, so we know the pressure is going to remain the same. We can like cancel those off. They're not going to mean anything. And then we want the volume to double. What would cause the volume to double? So what if we put a 2 right here? Okay, to keep these equations equal to each other, what would we have to do to temperature? Well, if we put a 2 on the top here, those two tops, 2 over 2 is equal to 1. We really haven't changed the equation much. So if the volume doubles, we know that the temperature is going to double. And remember, these little subscripts right here, that's just identifying which volume it is. It's not used mathematically at all. Okay, so you see here I've written down my knowns from the problem. The hard thing to figure out is that STP, that's a standard temperature and pressure. The temperature is always 273 Kelvin or 0 degrees Celsius, and the pressure is always 1 atmosphere. So you add those in. You've got, these are all your beginning values, and these are all your ending values. And you'll notice there's a problem. Here we have Kelvin, and here we have Celsius. They don't speak the same language. We need to translate. Also here we got ATM, and here we got kilopascals. So we need to convert those. Let's do that real quick. Okay, here's our equation. Let's go ahead and plug our numbers into our equation. Okay, there's our numbers plugged into the proper place. Let's simplify numbers and then rearrange to get our unknown by itself. Okay, here's our numbers simplified. Let's get V2 by itself. Since V2 and 2.66 are multiplying, it needs to divide on the other side. Let's do that. Okay, so it's going to be 0.742 divided by 0.266. Let's divide those. Okay, we get 2.78, and that's for our volume. Let's look at our units. We got kilopascals cancel here and here. We got Kelvin cancels here and here. All we're left with is liters, so our unit should be liters. And that's our answer. Okay, so I've done 3 problems with you. If you look on your sheet there from today's agenda, you've got a lot more to work on. That's for you to work on in class today. Also, you need to get your amounts and ingredient list submitted through Echo so that you can start working on your sodas on Thursday. Okay, so you've got that to work on. Also, we're going to be doing a we're going to be using Photoshop to make our advertisement, so you also need to start working on that and making sure that's ready for Thursday as well. So you got a lot to work on, and if you have any questions, please email me. Thanks, bye.